Module 3. We're going to start looking at, we're going to build off of some of the stuff that we have already done, and this time we're going to start milling around the outside. So we will take this part that's on your screen and on my screen, and it's Module 3. This is the video. So your assignment will be one that looks very similar to this, but it'll be slightly different. In this, we'll face the top of it. We will mill all the way around the outside of the part. So imagine we've got a piece 1 by 2 by 2 1/4 inch stock, and will be chucked up on about 100 thousandths at the bottom. We'll have 875 finished when we're done. We'll go down just a little bit deeper in that so we can flip it over and face off the bottom side. We're going to make this slot at 550. We're going to make this hole in it at 1 inch. We got some 1/8 inch holes. Looks like 4 of them on there, and really they're spaced 1 inch by 1 1/4 inch, but they're really not 100% central to the circle on there. Looks like we got some fillets on the outside, so some corner radiuses going around the outside of it. So your assignment, like I said, will be very similar to that, but not the exact same thing. So let's get started drawing the part and creating the model, and then we can kind of work from there. Okay, so I'm going to move this guy out of the way, just so I've got the reference of it over here on my screen. And let's make sure we've got this thing kind of pushed into view. Looks pretty good. Okay. So we are going to start. So I've got a blank screen. I've just got my Fusion pulled up. I've been playing with it for about the past hour, just kind of making some new drawings and new designs for some of the upcoming projects. So here I am. I'm going to start a new design. I'm going to go ahead and go on up to the top because I want my Z to be in the positive, and go ahead and click here. Just get my plane set up, kind of get my grid set up, and so as I'm looking at my part, it finishes at 1.8 by 2.3. So I'm going to go ahead and grab my rectangle square. I'm going to go ahead and drag that thing out. And it is 1.8. And I'm going to tab over, and I'm going to 2.3. Okay. And whoop, go ahead and click that for OK. That looks good. Finish that sketch. Twist it just a little bit, and go ahead and make an extrusion out of that. I'm going to flip it down the other way. I want to go negative 0.875. Drag that thing down. That's my rough outline shape and square rectangle, I guess. I'm going to go ahead and hit the outside corner radiuses. I'm going to bring the print back in here for view. Let's see. Put it right here for a second. Let's see, we can move the part around. Got this part sitting right here, and we'll pop that guy up. Where did she go? Okay, so if you can see it well enough, get some of this other junk out of the way. I'm going to go ahead and hit these 1/4 inch radiuses. So 1/4 inch typical in 2 spots, goes all the way around, all the way down on it, I should say. So we'll start working on that next. And so typically I have some type of pattern that I work on the part. That's not, I made this part earlier, but so this is really my second run at making this thing. And not always do I do it the same way, but I generally have a pattern. So I'm going to hit this corner as well. And I got 2 edges selected. I can go ahead and go in and put those in at 1/4 inch. You can see it changed to 1/4 inch, and hit OK. Now I'm going to do what oftentimes gets forgotten. I'm going to hit save. So I've already created a MACH134 Module 3 folder earlier, and I am just going to call this Module 3 video step by step. Okay. So we'll save it, and then now I've got that thing ready to go. Got it dialed in so that I can use it. So you can see it up here. It's named. And next thing I want to do is I kind of dealer's choice on this next thing that I want to do. But probably what I would do is I'll work from left to right. I'll put my slot in first and then maybe do the circle and then do the 4 holes around it. Okay, so I'm going to go in and create a new sketch. It's going to be right on top there, and it's going to be shaped like a rectangle. It actually will be a rectangle. It will be 1.8, automatically hits that, so I just tab out, I go 5.5, and good. So now I've got my width established and my length of it's going all the way across the part. So go ahead and grab this dimension button here and go from this edge and to this edge here, and it needs to be 200 thousandths off the edge, I believe. And there we go. So we've got that. Finish that sketch. So from here, now this looks a little wonky down here. Could just be the way that I'm tilted. Let's just see. So what I could do, actually I might just try that. Go ahead and put the circle in next, and then I could extrude both of them. I'm already here. I kind of like to work from left to right. So let's go ahead and extrude this thing down. And we're going to go ahead and go down -0.375 is the depth for that guy. And we're going to cut into it. So we hit OK. And we've got a cut in there. Now, if you remember from last time that we talked, we've got this timeline building down at the bottom, and it's just a really quick way to kind of see everything that we're doing. So this is just playing through everything that we've done so far. So it's just a replay of the build that we've gotten here so far. All in all, we're pretty simple. We've just got a rectangle that's been extruded down. We've got some radiuses in the corners here, and now we've got a slot that runs through it. 200 thousandths of the edge, 550 wide, is 375 down. Next thing I need to do is put a circle in the middle of the part. So that circle, let's see, we're going to take and we're going to create another sketch. And so sketch, put that right on the front there. I'll put that circle right in the middle. Nope. Yeah. Yeah, let's see, let's put it right there. And we're going to go to 1 inch, so 1.0. And then we need to go ahead and pull it around to the middle. So I think we are here would be 900. And then my other dimension from this edge. Gosh. I'm looking back on my print and I don't have that dimension there, so let's just say that that is 0.75. Okay. So we'll take care of that guy right there, and so we've got a hole there, or a circle there. Finish that sketch, and then we will continue to do the same thing. So if you notice, we're kind of going just in a rhythm. Draw the 2D shape, extrude it out. Draw the 2D shape, extrude it out. Draw the 2D shape, extrude it out. And so that's the pattern of a lot of these more simple designs. So here I just clicked on my circle. I want to go down 375, so -375. Got my extrusion in there. It's cut. Pretty good at this point. Moving along through it pretty fast. So if I get flipped around like this or upside down, I can just keep rotating myself back around, getting in the spot that I want. I've got shadows set up so that I'm kind of going in the plane that I like. It's just more of a personal preference on that. Okay, so now I want to hit back to my top. I want to go ahead and create some holes. Now in creating those holes, those 1/8 inch holes, and there is 4 of them. What I'm going to do is I'm going to create a hole, single hole, on this face right here. It is going to go through, and it's going to be an 1/8 inch diameter, so it's got to go at least 875 deep. And I will go ahead and put it into place. And let's see. So I'm going to hit here, get some dimensions, and I am, let's see, from that edge, according to my print, I am 1 inch, 264 thousandths. Okay. Now I'm going to go ahead and click this next edge and get it, and it is going to be 250 from the top edge. That's my first hole. Okay. You can see the gray behind it, so that means that that is a through hole. Okay. So we've got that. Now I can continue on and draw myself out 3 more holes, or I can go over here to this little grid looking thing. It's a grid. So next thing I'm going to do is I'm going to select the object that I want to copy. And so that's what I'm going to do. I'm going to make a rectangle pattern. And I'm going to go over 2 holes and down 2 holes. And those holes are going to be spaced 1 inch apart. And I'm going to go 1.25 down. And I'm going to show them. And let's see, I have not clicked a direction. So direction is going to go this way. Sorry, I got out of rhythm. I should have went top to bottom, and I did not. So I'm going to go 1.0. Let's go. I can either go negative 1.0 here, which is probably easiest. Get it on the other side, and then my other directions would be going down here, and then that direction. Whoops, need to click that down to 2, and then we'll go to here at 2, and then we'll go down here at 1.25, and that creates my square. See, it's starting to form there. And so I have my object selected, and I need to pick direction. I need to kind of follow the pattern from top to bottom. It makes better workflow. So from there on out, I can click that, get my 4 holes. And see, almost drawing in Fusion or Inventor, HSM, whatever it is that you happen to draw in here, we're just using Fusion today. No lie, Fusion happens to be one of my favorite things. It's almost too easy to draw in it. You know, if you go back to the time, if you drew in 2D AutoCAD, to do this was a much more labor-intensive project. What you do is you find yourself kind of just writing a lot of notes, and you were not able to make such vivid 3D drawings. So that takes care of essentially my drawing itself. Again, I am saving, so it's grayed out, so I've saved up all I need to. If I want to just force a save, I can go into Save As and then save it again. If I want to go from the beginning again, just like we showed before, we can kind of go step by step all the way through it and get all of our steps. Anyways, that's just for show. So I've already created a drawing, so I'm going to go straight into manufacture on this thing, and I want to make this part. Now, I already know kind of how I'm going to do it. I already talked about it a little bit. I've got a piece of stock that's 1 by 2, 2.5 inches long. Hopefully somebody sawed it up and made it at least close to what it is. It's going to saw at 2.3. I know the tendency is to, if it's going to saw at 2.3, we're going to saw at 2.5, and then it starts to grow and starts to grow and starts to grow. Remember, you're making your end mill do a lot more work. You're not always saving parts. You're not always saving time, and you're not always making better choices in doing that. If the saw length is set for 2.5, 2.5 is the goal, okay? So in my manufacturing, I want to stay kind of going across this ribbon left to right for as most as I can. I'm going to veer from it just a little bit. I'm going to jump over here into some other parts and then hop back in. So I'm going to go ahead and do setup. And like I said, I'm going to have something that is 1 by 2 by 2.5. And so I've got I want my 0 point to be up here at the corner of the stock. Okay, so that means when I come in, I do my edge finding. I'm doing my edge finding from stock since I'm milling all the way around the part. Okay, I am milling. I can select my machine here if I want to. Choose this Haas. At this point, it really doesn't matter. No fixturing. I'm going to go ahead and move from left to right. I'm going to try to force myself to go top to bottom, left to right. Now, what I don't want to do is just do this standard stock offset of 40 thousandths. If I do that, it's really going to cause me some pretty big issues later on. I do know that I have about 100 thousandths around it that I need to work from, because we said it's 2.3. We're going to saw at 2.5. It's 1.8. It's 2-inch stock. So that makes pretty easy math. And now our top offset, I want it to be 50 thousandths. Again, that's just for easy math. Our overall part height is 0.875. So I want my bottom, if this is 50, I want my bottom to be 1.2. No, 0.12. There we go. And so now, let's see, I've got something just a little bit off here. So I'm 2.5 by 2. Not sure what's going on here. My height is just a little bit off. Let's see. Okay, because I'm up here on this corner, and I'm 1 inch 25 thousandths. My bottom offset is at 1 inch. Yeah. Okay, so let's go on down, and I still have a little bit extra of material. It's almost as though I've done a little bit of extruding in the wrong spot. I need to stop and go back and figure out what's going on there. So stop there, go back here, and I want to go back into the design, and I want to look here at this feature. I am 875 deep, but somewhere I've gotten off on my math. So let's go back to manufacture, and let's do this. Let's go back in here. We'll edit this guy. Going from left to right, top to bottom. We're going to go over here. Our side offset is 100 thousandths. Our top offset is 50 thousandths. If our overall part is 875 and our stock is 1 inch, then okay, 0.075 puts me, so just bad math on my part. Okay. So earlier I had said that we had about 100 thousandths to stick up. That's going to get much, much smaller. So I think what I'll do is I'll go ahead and just do this. Let's give ourselves bottom offset of 100 thousandths. And then let's give ourselves about 25 thousandths on the top. It is a stock piece. Again, that was bad math on my part. I might even just shorten this up just a little bit and call this 10 thousandths on the top, and then 115 thousandths in the bottom. Because I want to show you that what we want to do here as we're milling. So I got just a little bit up there that you can see, and then if I'm in the vice jaws 100 thousandths, I need to have it up just a little bit more. So at this point I'm okay again. Okay, so just a moment there, and I can come over here. I'm going to go ahead and use a new work offset today. I'm going to go to work offset of 1. That's going to be G55 on that work coordinate system. So everything else stayed in place. And corner X0, Y0, Z0. Easy setup on that. And I can hit OK. All right, so if I want to, I can name that here. And I'll just call this, let's call this the BF, no, we don't want to call it that, so we're just going to call it a mill set up 1 of 1. How about that? Okay, and that setup is done. At least we know what it is, where it is, and how it is. So next thing I'm going to do is start to work through milling around the outside of it. Last time we did no outside milling, we had a part that I was like 2.5 by 2.5, or maybe 2 by 2. All we did was some pocketing, some facing, and I believe a drill and tapped hole in the middle. So what we're going to do is something that kind of in the beginning of life, or in cam life, I probably thought was foolish, but now I think it's a little bit better. Feature Cam used to use it a lot, and they called it AFR, automatic feature recognition. And so what I'm going to do is I'm going to go in here and hit this adaptive. Now adaptive is going to try and start to work off of what I've got, and what tools I choose and try and do as much as it can. Okay, so I'm going to go in and just for fun here, I'm going to grab this 3/8 flat end mill, 3 flute end mill. It's got a flute length from the shoulder 875. Yeah, it'll do this part, but it'll just do this part. And really, for what we're working on, it's actually probably going to be right on the edge of even being able to do this part. Spindle speed and feeds and speeds, 90 inches a minute. Sounds like it's okay. I can either make some adjustments here. I love an even number. And bad thing about that is it's always going to change one other number. So we're going to say we're going to go at a 5,000th chip load, and we'll leave the ramping in and out and the plunging okay. So this end mill will need to be self-centering, or sorry, not self-centering, bottom cutting. Will need to be able to go down because it's going to do a spiral cut into this. And if it's not bottom cutting, you have a potential pretty good chance that you're going to have some problems on the bottom. Okay, so I'm going to go in here and I'm going to click the model. And I want to make sure I click the entire model, okay? And I really don't need that taken care of. I don't really need that. So I'm going to come over here. Now here's something that, actually I'm not going to do anything with this now, but I'll come back to this. Okay, so again, 3/8 end mill. Here's kind of where we're doing all of our stuff. Stock to leave. I don't want to bring this into finished cuts. I want to go ahead and rough it out and then finish it out. In the print, I'm giving 3-place decimal. 3-place decimal plus or minus 5, which would marginally be, depending on the end mill that you're going to work with, would probably be okay. We're going to leave 5/1000ths in both axial and radial. That should take care of everything there, and then I think I'm pretty set from here on out. And let's see what it looks like. All right, so what I've got is I've got some of it, but I don't have all of it. And so what I've got to do some working through. I've got the slot, I've got the internal, but I don't have everything. So let's go back in here and do a little bit of playing with this thing so we can get all the things that we need here, okay? So we are leaving some stock. Go back and see what I've missed here. I don't need stock contour. I can leave rest machining off or on. At this point, it's not going to, actually, for none of it is it really going to matter. I do want to grab everything in there that I can. And one of the things that I want to do is I want to change out where I stop. Let me flip it to the front. I want to, I actually don't want to mill the top of it. And I do want to go beyond the bottom of it. So the bottom of it, I got the model bottom. I want to go beyond it by about 50 thousandths. So you see it moving it down. Actually, 50 thousandths is going to be too much. So let's go 10 thousandths deeper. Then that way I can get beyond that bottom. That way whenever I go to my second operation, if I want to flip it over, chuck it in the vice jaws or a fixture or something, set it in here, mill off that back side, and then that way I'm not left with a little razor edge going around that. Okay. So let's see what we start to look like now. Look pretty good now. This is a lot better part. So now I'm milling around the outside of it. Flip back over here into this front view. Rotate back up. And as you can see, I'm coming through and I'm doing some clearing on this. Coming in here, knocking this guy out. I'm not doing any kind of facing on it. Though I could come in and take this 3/8 end mill and do some facing if I wanted to, but for the way I want to finish this part, I don't want to mess with that. It would be really redundant to come in, since especially I've got like 10 to 15 thousandths on the top. I'm going to end up cutting and recutting essentially the same thing, or I'm going to have some paper thin chips. So, but here's what I wanted to really show you is look what Adaptive is doing. Adaptive's taking care of all of my milling around the outside, leaving stock. My milling throughout the slot, leaving some stock, and my milling all in this pocket, again leaving some stock. It's coming down far enough that I can get below the part. I will, like I said, I'll need to do a little bit of work to my end mill to be able to get it to go all the way down. But this is really slick at this point. I mean, it's essentially one operation doing a whole bunch of stuff. Okay. So at this point, if I wanted to continue on with kind of this roughing out, finishing out option, I'd probably go to my holes next. What I want to do is I'm going to go ahead and come into my automatic feature recognition. Sorry, hole recognition. Now it's coming up with two different things because it technically sees two holes here. It sees some 1/8 inch diameter holes, 1, 2, 3, 4, and then it sees one 1 inch hole. I don't want that 1 inch hole. I don't want to mess with that thing. So I am just going to ignore the 1 inch hole. Okay, so now as I do my hole recognition, it's going to go ahead and just post out my 4 holes. Now, one thing I want to come back to in that is there's a lot of hole choices that it's going to come up with. Honestly, depending on what kind of a drill I'm using, I may not even spot drill these holes. If I've got a good little 3-flute drill, or maybe even a spade drill, and a nice little drill, it's small in diameter. You're talking about 1/8 inch, and it's got to go down 875 plus clear the hole, so another 0.3 times the diameter to get through there. It's got to go down a good solid inch to get through it. So maybe I'm spot drilling, maybe I'm not. At this point, I don't have a really good tool set up. I have them sitting here as 1, 2, and then 3, kind of maybe 3, 1, 2 is the way I should say it. But I've got the holes in there. I can keep working with that as I go. Okay. So here I've got my milling of the outside, so all of my roughing. I've got my holes done second. And then now I need to come in and do some finish work on this part. And so what I'm going to do is I'm going to go back and do some facing. I do not want to use that same tool. I could, but I do not want to. Go back in to grab my 3-inch Kinematic face mill. So I want this face, and I also want this face. So I want to make sure I go all the way across there. So 3-inch face mill, I'm going to go across there. I do want to extend it. Pass extension by, let's go 1.6 just to get off of that part. Don't need to do multiple depths, don't need to do any kind of stock length on there. And it should be good to go after that. Okay. So if I want to watch from the get-go, I come up here and take a look at this thing. So I'm milling around the outside of it. You can speed that up if you want to. And remember, it's trying to make good decisions as it goes through so it can be as efficient as possible. And that's why you're going to see it kind of do some things that may not make sense to you. Like really, it's taking care of all of the machining at the -375 depth right now. If I was manually machining that, that's not the pattern or path that I would take. But you're talking about seconds of decisions, and it's good enough for what we're working with. Now, if I was making billions of these, well, first of all, I probably wouldn't be making them quite like this or with these tools. But in what we've got, if we need to make 100 or less, this is an appropriate way to do this. Okay, so that should be pretty close to my final depth. Okay, that tool's done. Got 4 spot drill holes. Now, if you'll look, as it's peck drilling, it's not coming all the way back out. That's one thing that I want to do some changing with. But I am spot drilling deep enough to leave a little bit of chamfer on top of it, just so my deburring operations go a little smoother. Face mill is done with a nice magenta. Okay, so we can stop there. I still need to come through. So essentially all I have done in finish land is the holes are done and this top face is done. I'm going to go ahead and save. Now, at this point, I'll go ahead and I want to knock out the outside of the part. I want to knock out the hole, and I want to knock out this slot. To do that, I'm going to go ahead and go into contour. And similar to adaptive, I can really probably do this all in one shot. So I'm going to come up and I'm going to grab a new tool, and I'm going to grab my 1/2 inch end mill. I know I just passed it. 1/2 inch flat end mill, and grab that guy, and it's a 3 fluter. It's not really a 3 fluter. We'll do some editing on that as we go, because RPM and stuff can be changed on that. Feed per tooth is okay. I would typically tell you need to make sure those things are right before you get started. That way you're not going back and forth over the top of yourself. Okay, so anyways, small distractions. Go ahead and select my contours that I want to work off of. I want to go down. I want to mill all the way around the outside, so I'm going to click the bottom of this thing. Get down here so you can see this thing move around. All I do is click the bottom. Red arrow shows the direction that I'm cutting. Okay, so now I'm going to come in. I'm going to hit this side, and then I'm going to come over here and hit this side. Now, since I've got a 1/2 inch end mill and this slot is 550, if I remember correctly, I don't have to worry too much about doing any kind of special feature for the bottom, because you're talking about an end mill that's 50 thousandths smaller. It's going to fit into that hole or into that slot. So now, same thing with the bottom of this thing. I'm going to come in, do the bottom of that. It's a 1/2 inch end mill. It's a 1 inch hole. My math is going to take care of itself as it goes. Okay. So let's take a look and see what that looks like. That's pretty dope. So we're going to come through here. One shot took care of all of my contouring. Now, there are some pros and cons in doing that, okay? Now, first of all, I will say this. I probably would not, even though I'm kind of showing adaptive today, this is probably not the path that I would take for all things. It's a little small of an end mill to be doing all of this work. It's going to take a little bit extra time to do it. Today wasn't really about speed. It was just showing that you could do this, okay? Always, always, always try to get the biggest end mill that you can into the hole or the feature that you can, within reason. Give yourself enough room for clearing out, for finishing, for moving around. But so for today was more demonstrative than anything. I want you to see that you can use this one end mill, and we've done that in class before. So here I've got all of my finished work taken care of. Now do a quick save. Now so say I want to. We're just going to call this 3333, and we're going to call it, I'm going to do a caps lock module 3. And I'm going to pick a milling operation, and I've got a Haas, and I've got a UMC 750. Again, here you got a lot of personal preferences as to what it is that you want to have inside of here and what you don't. Some of these things are going to make some things go a little bit faster. G187 will make life just a little bit smoother depending on what kind of options you have on your machine. So you can start looking at just a little bit further ahead. Chip transport, if you got a conveyor on there, we don't have conveyors on our machines. So forced home position on indexing, you can have that. You can have optional stop automatically. Show up. You can do preload on tool. Preload for tool doesn't do us any good, because honestly, even though I picked a UMC 750, I'm probably going to run this on a VF3. G28 instead of G53, to be honest, that's probably something that I would check. Just that's a personal preference. I know, I guess I'm a little more familiar. Maybe I get a little more warm and fuzzy with a G28 than a G53. A G73 option, and that's kind of what I want to go back to in some of this stuff is the outputting of code and what it's actually going to be doing. Let's look at operations. At this point we have nothing selected, so we're going to select everything. We want to do all things from this particular operation. So I can hit OK. I could also hit post at that point if I wanted to. I'm going to come in, I'm going to do a quick save. Now let's go ahead and just look at the entire program. So I can go ahead and go to Sorry, I shouldn't have done it like that. Come back up here to my NC program and do a right click from my NC program and hit post process. Come down here and hit view NC code. That's probably my smoothest, best process. Again, you get intensely long code in outputting using a CAM system. You're getting much longer code because you're using, in the beginning, you're using this 3/8 end mill. And if you're the programmer and you don't care about how long the code is, that's one thing. If you're out on a machine and you've got a lot of code in your library, this could start to be an issue for you. Here's where we went to G28 instead of G91, or I'm sorry, G28 instead of G53. If you do a G28, you have to go back to a G90 afterwards. So what we're doing is we're going to go inch input, G20, G91, Z0, our spindle go all the way up to the top. We go back to absolute programming from there. We went to G54. I thought we had clicked 1 in before, and maybe 1 is 54. I thought 1 was 55. We are absolute programming. B and C is 0. Again, I said we're probably going to run this on a VF3, so it's not going to matter. G43, H3. H3 matches up with our T3. We don't have any cutter compensation that's happening here. That's probably something that I want to change. So as I go to my last tool, my 1/2" end mill, if I go down here, I've got no G41 in there. So that's probably a problem for me. I'd like to have a little bit of control inside of the program, so or at the machine, I should say it like that. So that's a problem I want to go back and do some fixing of. Also, here's my spot drill situation. So spot drill's here. Spot drill I'm happy with. G81. First location. My depth. My retract. My feed. Next 3 locations. Kill the can cycle. Wrap it up. Turn spindle off. Go back home. Now, I want to drill 4 holes. Look how much code we got to drill 4 holes. Went past it. It's a lot of code to just knock out 4 holes. Now again, if I only store 10 programs in my machine, probably not a big deal. I probably am going to store more than that in my machine. So what I want to do is I want to go back and do just a little bit of tweaking on 2 things. One, my 1/2" end mill. I'm going to go back into it, edit that tool, and I want to choose a new option here. And so I want to do on my 3rd option down, compensation, and I want to do in the control. Now I choose a little bit smaller radius. Let's go 50 thousandths radius on that. And tolerance wise isn't going to make a huge difference, but I do want to continue to mill on the left hand side. By going into the control, I'm turning cutter compensation G41 on since I'm on the left hand side. That's going to give me the ability to make some adjustments out on the machine. If I do it in the computer, anytime that my tool starts to wear out, I'm going to have to go in and edit my code, or I'm going to have to go back and repost out. I want to try and save myself some problems right now. Okay, so I get a little bit of a problem. I've got the outside going good. I've got the inside hole going good, but my slot will not generate. So I got to find out what's my problem in my slot. Well, my problem in the slot is about where I start my my moving into it. The machine wants to come in with some smooth sweeping motions. That way it stops that little undercut or that little divot that you get in. So you can see, let's flip to the top here. My tool wants to come in, do a partial circle in, go all the way around, do a partial circle out, and then come out. Same thing here. I want to do a partial circle in, I want to do a partial circle out. Ditto over here on the 3rd try. At 5 thousandths radius, like my issue over here is I've got a 550 slot, I've got a 1/2" end mill. If I was still in the 3/8 end mill range, no problem, plenty of room. 1/2" end mill, I've got a beefier, stronger end mill. but I have a lot less clearance in there because I only have a maximum of 50 thousandths. That's when I'm done. Now I've left some material on here. I left 5 thousandths on each side, so that means I've got like 40 to deal with inside this thing. If I was manually programming it, I would just come over here, straight corner it, come in, shoot, cross, back and forth. I can do that here if I want to. But this is giving me some options to be able to come in and do some nice sweeping radiuses. I get a better finished product from it. And to be honest, I could probably tweak up just a little bit of in my starts and stops. Probably come in on this one side. Wouldn't be my preference. I'd probably come in at a corner at some type of area instead of this giant flat. Now, if I was going to do another operation and cut this off of there, that'd be fine, but I'm not. That would be something kind of foolish to do, so I could change the start point of where that was at if I wanted to. So I've got that taken care of. That makes my program a little bit better. If I just want to output the code for just that, I can take a look at what it looks like. And we'll just go to post code, and we don't really care what the number is. I always write 1001 over and over and over again. So now I should be able to come in here and see. This is just that half-inch end mill, tool 2, half-inch end mill. It's going down 885. That's what we had told it to. We wanted to go down 10 thousandths. First cut's at 385 deep, and that's as I go in. That's my circular interpolation. Here's what I've been wanting to see: G1, G41, X and a Y with a D2. D2 matches T2, which also matches G43, H2. Okay, so I'm happy there. Let me go ahead and pop back up here and edit something up here in the post processor. We're going to go up to 2, come back, save that, so I now should be outputting in G55. One more thing I want to change. I'm okay with spot drill, but I had said earlier I was not in love with that. So I want to come in here and just actually pick the tool operation itself. I'm going to go back into edit. And I'm going to come in here and I want to pick, instead of chip breaking, I want to pick deep hole full retract. And occasionally it'll say use cycle if it's possible. By doing this, it should take care of what I want it to do, I believe. So we'll do a quick save, and I know I'm kind of heavy on the saves. So I just want to output just that one itself and see what it looks like. Look how much smaller that is. So we had like 1,000 lines earlier, and now we've knocked this down to 25 to 95, skipping in 5. We've got a short amount of holes. So we're doing a G83, G98 for initial level return, and then I got my X and Y, I got my Z, about 950 thousandths. My retract is almost 200 thousandths, a little high for me. No kind of dwelling that goes in there. Probably my Q is a little bit off, but it is a small hole, so I can live with some of those other things. Probably the 190 would be the thing that doesn't keep me awake at night, but it would irk me just a little bit. So I've got just a little bit better part now. I can go ahead and come back up here from the top and run it through a simulation. I've already seen it work once, so I'm just going to kick it up a little bit faster. Okay, so holes that go all the way into the part. They don't come out the bottom, and that's okay. Everything that's yellow is something that my half-inch end mill did. My magenta, sorry, first day speaking. And my magenta is a 3-inch shell mill. My stock size was the green, and so it's left. You can't see anything left of the 3/8 end mill. Now, again, I don't think that this is a perfect part, but I think it's a functional part. And really today is about kind of showing some different functions, just kind of how to use these same tools and get a lot of different results out of them. Okay. So let's take a look at our setup sheet and see what we look at for time wise. Setup sheets, and pop that baby up. And I wish that Fusion would go ahead and spit out a PDF file of that instead of an HTML. 2.5 by 1 by 2.5 by 2 by 1. Let's see. It's telling me my work offset. It's telling me my tools. Probably need to go in and do a little bit of cleanup on that. I've got operations that are running my adaptive. So I'm going 3, 1, 2, 1 again. I've got some issues. My operator would have a fit with this because he wouldn't quite know exactly what it is that he's supposed to be doing. I've not done a good job of making sure that he has the right information. So I'm going to go back into this adaptive, and at this point I can do a couple different things. So I could come back into just the tool itself, and 3/8 2 flute. Let's call this tool. Let's call it tool 10. We'll go down in numbers. Feeds and speeds. 90 inches a minute. Force it up to 5. Everything else looks okay. Let's say that this tool cuts 900 thousandths deep, and the shoulder length is 1 inch. Body length is 1 inch. Okay, everything else looks good. This is a 3 fluter that I've got, and everything else looks pretty good. Now, preference would be that you go to your tool library and work with your tool library first. Here's why I want to do it this way. I just want to show you multiple ways of doing this. If I do it this way, I go up into my tool library. I go to my SFCC tools, I go to my 3/8 end mill, and if I go to edit this tool, it did not. See, those things are not the same. It only edited for that one particular tool. And so if I'm editing a tool that I'm going to be using over and over again, I need to go to the library first and then regenerate that tool, reattach it to it, and then work in the other direction. So if I'm just using it for this particular one, no big deal. But if this is what my end mill truly is, I need to make sure that it's in my library to start with in a correct way, so that I'm not continuously doing this over and over and over again. Imagine using your 3/8 end mill 4 or 5 times a day, and you have to go in and edit the tool 4 or 5 times a day. It's a lot of lost time. As you can see, I've got a red exclamation point there. I can go ahead and fix that now a couple different ways. I can right click, I can go over to generate, and then just rebuild that. Takes care of it right there. Another way I can do it is Control G, I believe, is going to take care of all of them at the same time. And so really, from here on out, I can kind of just go, I'm going to go down 1098, so just down from top to bottom. So here I've got a spot drill. My mind says I've got a spot drill already set up. So instead of going to here, I'm just going to go into this operation. I'm going to go back over to the tool, and I'm going to go find myself a better tool. And I'm going to get that crazy thing out of there. I'm just going to delete that tool out. I'm typically not using a lot of metric style tools like that. Let's say I've got a ½ inch. I've probably got a 3 inch. There's a 3/4 inch. There's a 3/8 ball. Let's go ahead and use this ½ inch spot drill that we've already got set up. And so I could probably find myself using, here we go, 3/8 spot drill, 3/8 90-degree spot drill. It's tool 3 in the library itself. Now, if it's going to be tool 3 in the library all the time, fine. If it's not, then maybe I'm just going to put it in for this one. So then I'm going to go to edit tool, and then I might just change tool location. So 9. Okay. Control G will take care of all the tools that need to be regenerated. Let's see if we've got an 1/8 inch in the library already. If you don't, it'd be a good time to do something like that. Looks like I've got number 12 as an 1/8 inch drill. 118 on the point, so I'll go up in here, and I'm going to go in and edit, and I'm going to go back over to the tool, select that tool, go into my library, grab that guy, go ahead and hit OK, and then jump back in real quickly, edit the tool, and I think it's this one needs to be number 8. Okay. All right, I'm gonna leave that one alone. This is gonna be 7, and it is the correct tool because I pulled it out of my library. So the only thing I need to do is change the tool number on it. So I can actually just type 7. It's going to change my length offset and my diameter offset for it. Okay. But you can see I'm starting to kind of build some red exclamation points. If that's a problem for you, OCD wise, then take care of it. If it's not, then let it go. I've seen some of your all's work. It's not a problem for most of you guys. Okay, last tool is what, my 1/2 inch end mill. I probably pulled that out of my library. It's been 5 minutes. I can't remember back that far. So let's go in and edit the tool. Let's double check. Yeah, 1/2 inch flat end mill. What did I say? Flutes. I'm pretty sure that that's going to be one of the newer Kinematic Harveys that I've got. So it's a 4 fluter. They're not quite the ones that I wanted, but I'm not sure what happened in my ordering. Apparently I did something wrong. So this is going to be tool 6, and hit OK. So now I've got 10, 9, 8, 7, 6. Do a Control G, grab all those tools, fix all of them at the same time. Oh, I didn't have all of them highlighted, did I? Okay, and Control G, take care of all those. There we go. So a couple more moves of the mouse. If I need to, just because I probably like to watch this thing run simulation-wise, I'm just going to kick it up real fast. It's nice to look at that, but remember, it does take time to do all these things. And so the more we do this, the more we run through simulation in a day, the more time that we're taking up. And so it's the difference between getting 5 programs done in 7 or 6. So we want to try and get as many programs done in a day as we can, especially if we're the programmer and the operator, or the programmer and the setup guy, or the programmer, setup guy, and the operator. If you're doing multiple, wearing multiple hats. Okay, so at this point, I would probably call this guy done. What I would like to see from you is something similar to this. I would like you to use cutter compensation on your finish tool. Go ahead and use smaller ML to do all of this work inside of here, and then finish it similar to mine. Face mill, contouring around the outside of it. Make sure you're going down deep enough that you've got full height part left over. I'm 10 thousandths deeper than what my part is. You can go ahead and set your work offset at G55. So make sure that when you post out your code, that you're getting it. Let's take a look at ours and just make sure. Well, this is the worst place for me to grab my code from. I prefer to get it from here, from my NC program. Sorry, jump up here. Yeah, I said 3333, and then NC code, and let's see if I got to 55. Yeah, 55 is right there. I've got, like I said, pretty long code, but I've taken care of everything else, and I'm going 6, 7, 8, 9, 10. And let's do a quick look at a setup sheet, just because the last one was kind of junky. All right, so I've got 5 operations. I'm going 6, 7, 8, 9, 10. That should fit any of our machines. Estimated cycle time, 2 minutes, 36 seconds. If only you could set them up that fast. So 6 days to set it up, 2.5 minutes to run it. So here's our tools, 6, 7, 8, 9, 10. Here's our operations going 10, 9, 8, 7, 6. Okay. So that should take care of all of our stuff that we need to do. So what I want from you is your Fusion file, and I also want your outputted code. So when you do your posting, I want you to save it and then send it to me. And so here, if you're having a problem doing that, go ahead and hit save here. If I'm unsure of how to get that in, I can go to a file, save as, and then I can put it a couple of different places. You know, I can really kind of work around where I want it to go. And then I will save my Fusion file, go grab my Fusion file, and then send it to me. And then same thing with my outputting. I would go back in here and post process, grab it, open it, and then come up here, save it where I want to, just a place that works good for me, and then grab both those files and send them to me. I don't so much need your setup sheet. When I open up your Fusion file, I should be able to see everything else that's inside of there. So the part that you will get in Module 3 will be similar, but not exactly the same as this. Slot might be a little bit smaller, and so you just need to make some adjustments for that. It will have a circle, a slot, 2 corner radiuses, 4 holes, and it will be a rectangle in shape. Okay, get to work.